Okay, now let's go through question 11. A student sets up a circuit containing three identical cells. Each cell has the EMF of 2.0 volts. So what we'll know is that the three cells add up together, it will be 6.0 volts. Figure 11.1 shows a cell in series with a uniform metal wire connected between terminal K and L. Okay, so this uniform metal wire, there's a lamp over here and there's an emitter over here. Defining electromotive force, so this is just a definition. So this can be found in the textbook. It is the amount of work done used to drive a unit charge across the whole circuit. Okay, so this can be found in the textbook. I'm not going to go through too much. I want to go through a little bit more on B. Well, it says the ammeter reading is 0.25 ampere. So the ammeter reading here is 0.25 ampere. The metal wire has a resistance of 16 ohm. So the metal wire here is 16 ohm. Right? They say show the resistance of a lamp is 8 ohm. So because we know the total voltage, the V total, we know is 6.0 volts. We know that the current, because this is a series circuit, the current flowing through the ammeter is the current flowing through the whole thing. So this I total will actually be also equals to 0.25 ampere. I know the total resistance is 16 ohm plus the resistance of the lamp. So let's use V equals to IR. So V total equals to I total multiplied by R total. So I'm going to get is 6.0 is equals to 0.25 multiplied by 16. Multiplied by 16. Okay, 16 plus RL. So I'm going to get is a 6.0 divided by 0.25 equals to 16 plus RL. Resistance of the lamp would then be equivalent to, this will be 24. 24 minus 16, so I'm going to get is 8 ohm. Okay, so the resistance of the lamp I've shown is 8 ohm. Now, for the next part, I also find the power of the lamp. So the power of the lamp, P, I know P equals to IV. But if I look at the whole circuit here, I know the current flowing through the lamp would be 0.25 ampere. I know the resistance of the lamp is 8 ohm. So why not use another version of this formula? So if I sub V equals to IR into here, I know that P equals to I times IV. P equals to I times IR. Let me try to erase this. Oh, the eraser is not working. Okay, not V over here, is R over here. So this will be I square R. So to find the power of the lamp, P of the lamp will be equals to I of the lamp square times the resistance of the lamp. So the power of the lamp will be equivalent to 0.25. I square it, multiply by 8. So what I'm going to get will be 0.50 watts. So that's the power. Now, they say the input energy to the lamp is 16,000 joules. This is for part 3. Calculate the amount of charge flowing in the circuit. So for this one over here, I got energy, I got charge. So actually I need to use V equals to E over Q. But before I can do that, I need to find the voltage in the lamp. Voltage across the lamp. So to find the voltage across the lamp, I just use V equals to IR. I know I is 0.25. I know resistance of the lamp is 8. So what I'm going to get here will be 2 volts. So the voltage of the lamp is actually 2 volts. So using the formula V equals to E over Q, I know V is actually 2. I know E is 16,000. I know Q, I'm trying to find Q over here. So Q equals to 16,000 divided by 2. So Q is actually equals to 8,000 coulomb. 8,000 coulomb. Next one, part C. They say the student removes a 16 ohm wire from the circuit and cuts into 2 equal lengths. So 16 ohm now cut into 2 equal lengths. Each of this wire will be 8 ohm. He then connects a 2 length in parallel. Okay, so that's what we see here. In part 1, they say calculate the effective resistance of circuit if the resistance of the lamp remains unchanged. So I want us to focus at this part over here. Let's think in terms of how the whole thing is arranged. So in actual fact, the lamp is here. So this 8 ohm. It goes up, right? So we just imagine this part over here is just continue to go straight. Now I have two 8 ohms wire connected in parallel. So this is equivalent to connecting two 8 ohm resistors in parallel. So this 8 ohm is 8 ohm. So to find the effective resistance, okay, to find the total resistance, it's actually just 8 plus two of them in parallel, so 1 over 8 plus 1 over 8 inverse. So what we're going to get over here is actually 12 ohm. So the resistance here will be 12 ohm. Now for the last one, explain why the lamp gets heated up faster when the wires are connected in parallel as compared in series. So the difference between the parallel and series circuit is that you know that the total resistance when they're connected in parallel like this, okay, is 12 ohm. Whereas when it's connected in this manner, it's actually 20. The whole thing is actually 24 ohm. Right, the whole thing is actually 24 ohm, the total resistance. So what we're gonna know is that as the resistance of circuit is smaller, so when it's connected in parallel, it is smaller. So using V equals to IR, we know that the current will be higher. So if there's a higher current, it will actually cause the lamp to be heated up faster. Okay, so do take note of this. That actually a higher current will actually cause the lamp, cause any circuit to get heated up a lot faster. So that's all.